completing the square. Another way to solve a quadratic equation is to use the method of completing the square. So before we move on to actually solving some quadratic equations using that method, let's practice the method first. Now, when we complete the square on a quadratic, our answer will always be in the form of x plus or minus a all squared plus or minus b. Okay, so to get it into that form, we're always going to have this square bracket with an x and then plus or minus depending on this term. So we've got an minus 4 and we want to half that. So x minus 2 in the squared bracket. Then we always subtract. Okay, there's always a minus sign after that squared bracket. We always subtract this number squared. So minus 4 and then add on the 5. Tidying this up, so minus 4 plus 5 gives us plus 1. And we get x minus 2 all squared plus 1. And that is the square complete on that quadratic. When we get a quadratic that has more than one x squared, we're going to take out that factor, okay? So however many x squared we've got, we will take it out. So that then leaves me with x squared minus 1x and minus 2/3. Okay, so we'll concentrate on the square bracket here. And again, same principle as before. So we're now down to 1x squared in this square bracket. So just like we did in part A, we want half of this coefficient, which is just a minus 1, which gives me x minus a half in my squared bracket, minus the minus a half squared, so minus a quarter here, and then minus the 2/3 that we had. Okay, so we're subtracting two fractions here, meaning we need a common denominator. So we know minus a quarter is minus 3/12 and minus 2/3 is minus 8/12, which then gives me minus 11/12. Okay, so we then need to bring the 3 back in. So we're going to multiply the square bracket now by the 3 again. So it will be 3 upon that squared bracket minus 33/12. And 33/12, we can also take it down to x minus 3 upon x minus a half all squared minus 33/4 in its fully simplified form. Okay, part C then. First thing we're going to do is rearrange it, okay, to make it minus x squared plus 5x plus 14. Coefficient of x squared here being minus 1, so we're going to take that out as a factor, leaving us with x squared minus 5x minus 14, which means we can then complete the square on this square bracket. So half of the minus 5 is minus 5/2, so we've got x minus 5/2 all squared, and minus 5/2 all squared is 25/4, so subtracting that, and then we need to take away this 14. So to make life easier, we're going to write minus 14 as minus 56/4, just an equivalent fraction with a common denominator to make this subtraction easier. So minus 25/4 minus 56/4 gives us minus 81/4. And then we're going to multiply the minus 1 back in. So minus x minus 5/2 all squared, and then plus the 81/4. Moving on then to actually solving a quadratic equation using this method. So completing the square then, just like we've done before. So x minus 3/2 all squared minus the 9/4, and then again we're going to write minus 1 as minus 4/4 so that we've got a common denominator. Doing our subtraction then, we've got minus 13/4. So still an equation equal to 0. So we've got x minus 3/2 all squared minus 13/4 equals 0. And from here it's just a case of solving this equation. So adding 13/4 to both sides. Then taking the square root of both sides, remembering that we will have a plus and a minus. And then adding 3/2 to both sides. So our answer then will be x is equal to 3/2 plus or minus root 13/4. Okay, one now where we've got 2x squareds in the question. So just like before again, we're going to take out that 2 as a factor, leaving me with x squared minus 7/2x minus 2 equals to 0, and then completing the square on the bracket. So half of 7 over 2 being 7 over 4, so x minus 7 over 4 all squared, minus that squared, so the 49 over 16, and again writing this 2 with a common denominator of 16, so 32 over 16. Subtracting our fractions then, we get minus 81 over 16 being equal to 0. Okay, and because this is an equation, I can just divide by that 2. Okay, because it's an equation. So that will just leave me with the x minus 7 over 4 all squared minus 81 over 16 being equal to 0. Just like then in part A, adding the 81 over 16 to both sides, taking the square root of both sides. In this case, the square root of 81 over 16 is 9 over 4. So I have plus and minus 9 over 4. Adding on the 7 over 4 then to both sides. And I can actually work this answer out as a number or a fraction. Okay, so 7 over 4 plus 9 over 4 is 16 over 4, which is 4. And 7 over 4 minus 9 over 4 is minus 2 over 4, giving you minus a half. Okay, part C then, we've got a negative number of x squareds in the question. So just like before, we're going to rearrange it to get minus x squared minus 6x plus 1 equals 0. Again, our coefficient of x squared being minus 1, so taking it out as a factor, and we get x squared plus 6x minus 1 equals 0. Completing the square on the square bracket then gives me x plus 3 all squared, minus that squared, which is minus 9, and then minus the 1. So that gives me minus 10. And then we can divide by the minus 1. So that will just leave me with x plus 3 all squared minus 10 equals 0. Adding the 10 to both sides and taking the square root, so I'll end up with plus and minus the square root of 10, and then take the 3 away. Okay, and we can't do anything more with that answer, but just get x equals minus 3 plus or minus 10. Now, if this was a surd that could be simplified, we should obviously simplify that surd, but in this case we can't. Okay, moving on. Express 3x squared plus 15x plus 20 in the form a upon x plus p all squared plus q. Hence show that the equation has no real roots. Okay, so first of all, this just means complete the square on the quadratic. Okay, so just like you've done before, we've got 3x squared, so we're going to take the 3 out as a factor. So 5x and 20 over 3. Half of the 5 being 5 over 2, so x plus 5 over 2 all squared, minus that squared, and then add on the 20 over 3. Okay, so to tidy this up, we need a common denominator. So making them in 12ths, so 25 over 4 becomes 75 over 12, 20 over 3 becomes 80 over 12, and then minus 7 twelfths plus 80 over 12 gives me positive 5 twelfths. Okay, bring the 3 back in. And we can't divide by 3 in this case because it's not an equation yet. So multiplying the 3 back in, we get 3 upon x plus 5 over 2 all squared plus 5 over 4. Okay, that would be 15 over 12, which goes down to the 5 over 4. Okay, so the question then asked us to solve that quadratic equal to 0. So we've completed the square on it already. So using our completed square version of the quadratic, we can then go on to solve it. So just like before again, we're going to take the 5 over 4 away and divide by 3, which gives us minus 5 twelfths. Now, from that stage, what you would want to do is take the square root, but you should know from before that you cannot take the square root of a negative number, which is why in this case, we say there are no real roots, there are no real solutions. And the reason being that we can't take the square root of a negative number. Okay, now taking the method of completing the squares a step further, we can also use it to find out whether a quadratic curve would have a maximum or a minimum turning point. So in this example then, with a quadratic we're given, we're going to be able to say, does it have a maximum or a minimum turning point, and where does that value occur? Okay, so x squared plus 3x plus 4, completing the square as we have done in the last few examples. So half of the 3, square it, 9 over 4, and again 4 is the equivalent of 16 over 4, Tidy that up then and we get the 7 over 4. So we've completed the square on this now. And from there, I can say, well, this square bracket will always be positive. And because it's always positive, that means I have a minimum turning point. And if you think about it, this is a positive quadratic. And positive quadratics are always that U shape, meaning there will always be a minimum turning point. Okay? And the minimum turning point will happen wherever this bracket is equal to 0. So in this case, to make the bracket equal to 0, x has to be minus 3 over 2. So it's a minimum turning point because it's a positive squared bracket, and it happens where x equals minus 3 over 2 to give this bracket a value of 0. The second one then, with a minus x squared term, so I'm going to rearrange it to minus x squared minus 2x plus 2. Completing the square on it, so we need to take out minus 1 as a factor here, which leaves me, there should be a squared in there, apologies. Okay, so x minus 1 upon x squared plus 2x minus 2. Half of the 2 gives me 1, so x plus 1 all squared minus that 1 and minus the 2. So tidying up to give me minus 3 and multiplying the minus 1 back into it again. Okay, but in this case you'll see that the squared bracket now will always be negative because it has a negative sign in the front. And again, if you think about a negative quadratic curve, they're always that N shape. An N shape with a maximum turning point, okay? So anytime you have a negative squared bracket, it will always be a maximum turning point. Again, it happens where this bracket is equal to 0, in this case, minus 1. So a maximum turning point because it is a negative squared bracket, and it happens where x equals minus 1.